Can you hear me?
Oh, yes, I'm here, Daniel. Thank you.
Oh, okay, Kelvin. Thank you very much for joining us this year. We are very happy to have you here. I did a short presentation about you, but you can tell it better than me. And so it's time for your talk. Thank you very much.
Okay, excellent. Thank you. Yes, I speak very poor French and English, so I will bridge off of what Daniel said, but possibly not perfectly. But as a quick introduction, so I've been at Wolfram for a number of years now. I actually started at Wolfram just out of school. For bandwidth purposes, I put a picture of me here instead of using a webcam. I think you'll want to read my screen or take a look at what I'm typing anyway. But as Daniel mentioned, I'm co-author of the Hands-on Start to Wolfram Mathematica book, as well as a newer book on Wolfram Alpha Notebook Edition. And in general, I've done quite a few workshops and training sessions, mostly in the US, but sometimes outside of the United States. But I have a pretty healthy experience at this point with teaching people Mathematica, especially students, and especially people who have never seen Mathematica before, and help them take that first step and learn it for the first time. So we just came out with the 3rd edition of this book. It originally came out in 2015. The 3rd edition was released just a few weeks ago. So this talk is about sharing work, and in general, the theme here is about taking all the neat things and very useful things that you're doing in Mathematica, but how to share that with other people, whether they're a Mathematica user or not a Mathematica user, or just in general. So I thought I'd start by just showing the sample chapter here. So I'm going to show a lot of examples today about how to quickly show things and show quick ideas or sketches and do this very easily. But at the complete other end of the spectrum, this book, the 2 other co-authors and I, Cliff Hastings and Michael Morrison, we wrote this entire book in Mathematica notebooks. So with the sample chapter here, if you look at building a first model and this text and this calculation, so when we set out to write the book, in terms of the details of actually doing it, each chapter started as a Mathematica notebook. We worked with our design department to create a special style sheet. So all of the fonts and look of this is very deliberate. All of this is somewhat typical in Mathematica, but let me get here. So this we created with our graphic design department. And when you look in the notebooks, so the actual notebooks for this book, it looks exactly the same as this, where this is a special kind of text cell that we created. In the narrative of the book, it's designed to be an interjection. So something where if a learner or a student were reading through this and they get to this point, they might think to themselves, okay, that makes sense, but what happens when I do this certain thing? Or why are you explaining that? Are there other options? Is this the only way to do something, or just the preferred way when I'm starting out? So this is meant as an interjection in the book, but when we printed this, it all worked very, very nicely. So I want to just begin by showing, when you think about sharing and collaborating, if you have a large collection of notebooks, if you want to do something that is, really a involved project, these notebooks do scale up to be print quality and to look very, very nice. I believe the actual process was going straight from notebook to print-ready PDF, and then we sent PDFs to the printer, and then the printer, created paper books, and then we created a Kindle version of this as well. But, in general, there was not a complicated, restructuring of the content based on tech or some sort of Word or intermediate step. It really went straight from notebooks to PDF with a bit of graphic design. But notebooks do scale up to, to be good enough for a pretty big project. Now, most of what I'm going to talk about today is really on the other end of the spectrum. So I want to begin just briefly with my history with Mathematica. So I mentioned I've been at Wolfram for several years. When I started at Wolfram, the first machine on my desk was the original iMac. So these little machines where they were in these neat colors. So you could choose colors. I think mine was blue, although my memory is getting a little fuzzy on that. But you know, I used Mathematica on a Mac machine. It was the Mathematica version 3 days. And so one amazing thing about Mathematica is the things I was doing in version 3 still work today. I mean, certainly the language has grown a lot and the things that I'm doing are very different, but you know, it's adding versus redoing or changing. So the scope of what I can do grows over time, but you know, the same things that I was doing on this old Mac machine, which was one of the first OS X machines, you know, today on a MacBook Pro, you know, in general, it's amazing that things have not changed all that much in 20 or so years. Now, what's changed is what's going on around us. So this is a picture from our scrapbook of how the Wolfram Research website looked back in the days when people were using Mathematica version 3. You know, the web itself was a much, much different thing back then. It was very young. People were just starting to create websites. The Wolfram website at the time was very good compared to other websites, but you know, looking at it now, it looks very well. I mean, it looks like an early website, whereas today, and hopefully you bumped into this at least a little bit. So today, this is a screenshot of when I traveled to campuses before the pandemic, when I was traveling to campuses, but you know, I could go to a website where it was an embedded notebook with some text and some charts and some interjections here. But, you know, I'm to the point where I can give presentations where I can show up at a campus, I can log into Mathematica Online or Wolfram Cloud, and I can pull up my presentation and I can present from anywhere. I don't even necessarily need to bring my laptop anymore. I could bring an iPad, I suppose, but I can set up and just give presentations from anywhere. So although my use of Mathematica locally feels kind of the same, I mean, Mathematica has grown a lot, but you know, the paradigm of you download Mathematica, you install it, you work with local notebooks. Local notebooks were really good in version 3, and they're really good now. While that has not changed a lot, what's going on around Wolfram, and I think the usefulness of the web in general has changed quite a bit. So I'm going to talk about my perspective of how can you leverage that, how do I leverage that, and then I'm going to show a lot of more bite-sized examples of little things that I've built with other faculty members or other researchers or other people in industry, and some real-world examples of how this can look. We're going to have a Q&A as well. So throughout, I may or may not be able to look at the questions pod as we go, but if you want to put some questions there, we'll have some time at the end where either I will read through those or Daniel will read through those, and you know, we'll pick out some questions. So feel free to do that while I'm talking so that you remember those questions, or at the end you can write your questions then. Either will work just fine. Okay, so when I was thinking about this talk, this keynote, and thinking about my perspective of, you know, what do I do differently with Wolfram Cloud? Just yesterday, I was reminded of something that I do that's a lot different, actually. So one of the activities that we do at Wolfram is, in conjunction with the book, we have a free seminar. And actually, the hands-on Start to Wolfram Mathematica videos predate the book. We have, for a long time, had videos that are a really nice half an hour to get started with Wolfram language. It starts with a completely blank notebook, and it's, you know, you type along with the trainer. Most of the time, that's the co-author, Cliff Hastings, and then I help with questions. So this seminar is a live version of that, where people start with a blank notebook, they type along with Cliff as he is creating his first notebook, and then we run this in GoToMeeting, very similar to the environment that you're looking at right now. So just as I've told you to go to the questions pod and ask some questions at the very end, I tell new learners or students to do that as well. But in that case, the questions that they ask and the answers really need to be prompt. So if in the first 10 minutes, maybe they cannot figure out how to get the solve command to work, or maybe they've forgotten a square bracket or something like that. It's a 2-hour seminar, so it's very important to get them back on the right track and have them successfully do those first couple calculations and really help them very, very quickly. So that's usually my role, where I am looking at the questions pod, but I'm responding very, very quickly to keep students on track so they can go back to listen to Cliff and keep going. I've noticed over the last, I mean, we've done this now for, I think 5 years, maybe longer. So I've noticed over the past 5 years that how I answer these questions has gotten a little bit different. So from my perspective as the presenter, you know, you're looking at GoToMeeting and there's a button that you can click on and you can see the questions. From my perspective, it looks more like this. And this is how this looks today, where I can see all the questions and we assign them to certain people. And then though, I type in this little text pod when I want to answer this. So it is a very instant message kind of environment. So just yesterday morning, I got a question about midway through the seminar. It was someone who knew the basics already, and they really wanted to, you know, just create a chart and take the next step, basically. So they asked, how can I create a pie chart that summarizes the quantity of words in a list? So at the time, we were talking about the part command in filtering data, and we were going through some simple examples. So a couple things I've noticed that I'm doing differently. So 5 years ago, I was creating an answer in local Mathematica, copying and pasting that into the chat pod, and then sending it back to them. I am no longer doing that. I also often just send a link to our documentation. So the web version of our documentation, I was often sending that in the chat pod as well. I am less frequently doing both of those. Now when I answer questions like that question above, it is much easier actually for me to create a little notebook. So really their question boils down to, is there a function like tally, where if I've got certain words in a list and I want to count them and then make a pie chart, the part command is useful, the tally command is useful, and then they really were asking about the pie chart function. But as is often the case when people are learning Mathematica, there are these intermediate functions where they are very conveniently built into the language, and once you see them once, you know, that's something that this person will, you know, do forever probably in Wolfram language, but they just need to see this once. They need to see how this looks. So really what I do now is I create this in local Mathematica and I publish it, and then I send this published URL. So this is a public URL that I can send anyone, and then I can just put this in the chat pod, and then what they get is a more permanent answer. So after they click on that, it opens in their browser. They can keep this after the seminar. It also includes the full result. So sometimes when I send people just an input and I copy and paste an input, they probably look at that after the seminar is over, but in this case, they can look at this right away and they can say, oh, that's interesting. Is there a way to recolor this? But they can ask a follow-up question immediately, and then I have a much better back and forth with people. So while I answer questions in local Mathematica often, just being constrained to that chat pod, having a published notebook where I can give them an answer, they can see it in the web. Often people attend these seminars on an iPad or even on a phone, and they can see the answer on their iPad as well. So even if Mathematica is not on that particular machine, they can still see the answer. And in fact, now that people are doing things remotely, they will often watch the seminar on an iPad and then have their main laptop with Mathematica where they're really typing. So that's actually a very important piece. But I think that is one example, one very drilled in example of many where I'm doing things differently simply because I can put a notebook in the web, and I find that very, very handy in a lot of very specific circumstances. And there are many of them. Maybe someone is in several meetings throughout the day, but we're collaborating on a project, and I just want them to look at a chart and comment and write me back on their phone during a meeting. They can do that now. Or this example is a good one. Or maybe we both want to append to a notebook. I'll show how to do that later. But anyway, I think I've tried to outline kind of the very involved end of the spectrum, where notebooks and sharing notebooks and having that go into a full book. I have experience with that, and that's worked out very well. Or the other end of the spectrum, where I just want to very quickly share a very a very micro level idea that I've whipped together very quickly. But quickly is very important, and portability is very important. I think so. All of this technology has changed how I do things in a lot of ways, but in both ends of the spectrum, basically. Okay, so what is Wolfram Cloud? I think that I'll give a very general answer, but there are a lot of answers to this. In general, Wolfram Cloud is a technology. So when we talk about Wolfram Cloud as Wolfram the company, that is the underlying technology that goes into a lot of different products and projects here at Wolfram. It is commonly licensed as Mathematica Online or Wolfram One, so you can use these somewhat interchangeably. So if you say, I'm using Mathematica Online is the thing that you're looking at in your browser, but in the background, it's using Wolfram Cloud as the technology. In general, it is browser-based notebooks and calculations, so that makes things very portable. I'll show that in a little bit. Publishing and sharing notebooks, I was just showing a published notebook, so I think of this as being very inclusive, where if you've got a project and you want someone to take a look at your results or just read through what you've done, they no longer have to have Mathematica or be extremely familiar with Mathematica. If you want them to check over, just some code or something, they can read a published notebook, and it's, and anyone in the world can read it immediately, which I find very, very handy. And then the last thing I'm going to talk about is web forms. So this is sort of the conglomerate of both the first two things. So, for example, if you want colleagues or students or someone to do some live calculations based on what you've done, but again, maybe they don't have Mathematica on that particular device, or maybe they're not Mathematica users at all. These web forms that are possible in the newer version of Mathematica, this makes it very convenient to have them do live computation based on what you're doing. There are many other things that Wolfram Cloud does well that I'm not going to really touch on a lot today. So for example, if you work on projects in a mixture of languages and you want to call Wolfram language code as a REST API, you can do that now. There are very useful things for Internet of Things, so IoT devices. We have a lot of repositories. The repositories are getting more and more interesting all the time. So we've got a repository for user-defined functions. We've got a repository for data sets. We've got a repository for neural nets. So these repositories are very useful. And then, of course, there are things like cloud storage that are built in, or a lot of the building blocks to make all this work. But I'm mainly going to talk about these three things today. Okay, so in terms of portability, I'm going to show you just a couple examples here, but I think of this as while I use my main laptop with Mathematica still as my primary device, and for reasons of bandwidth today, since I'm sharing my screen and sharing audio, I'm running this in a local Mathematica instead of Mathematica Online today. But in terms of portability, a notebook is a notebook across a lot of different devices. So things have the same look and feel, which I find very, very useful. This is just a sample notebook where it's a simple discussion about a sine wave. There's some text that I took from Wikipedia that links to Wikipedia, so it can have a hyperlink, and then a simple plot. But this is the very familiar classic notebook environment where I think probably many or most or all of you are familiar with this, how this looks in a local installation of Mathematica version 12. If you look at this in browser, so this is Mathematica Online in wolframcloud.com. This is my account that I log into. If I save this file or create this file and open it in browser, it looks exactly the same. So if I am visiting someone else, a colleague's office, and I want to just go to their machine and log in and show them something, I can do that. And it all works very, very nicely. It looks the same. There's also a Wolfram Cloud App that works on either Android devices or iOS devices. So this is the Wolfram Cloud App on iPad. And again, if I log in, the notebook looks the same. On iPad, there's a really nice keyboard as well to type things in that's very specific to an iPad. So for example, you can't hold down Shift and Enter on an iPad. There's no keyboard, generally speaking. So there's a button that says Evaluate that helps you do that. But since Mathematica Online is doing computations on our servers, really all the iPad is doing is displaying the notebook, and then it goes off to our servers to generate plots or to do calculations or to generate mouse-driven models. And so it all works very, very nicely. And in fact, it works nicely when I'm on a wireless, either at my house or a campus, but it also works very well on, going back to 3G or 4G, just a general cell connection. It works pretty nice with that as well. I can't say I've tested that very thoroughly, but in major cities, it works pretty well. This is a look of this on iPhone. So again, it's the same Wolfram Cloud app, where if you look at this on an iPhone, it is very usable. Of course, an iPhone is a very small screen, so it formats the text very nicely. I can read this. I can look at the plots, but it's very, very usable on an iPhone. And if there's a slider on an iPad or an iPhone, I can use my finger to move a slider. I don't have to have a mouse. Of course, I don't have a mouse on an iPhone ever, but there are things on the app that make this a very convenient use, or a very convenient way to use notebooks rather. But my main point here is it does not look wildly different. It's not a completely different environment. A notebook is a notebook is a notebook on all these different environments, which is really nice. Okay, so now I'm going to show how to publish a notebook. I'm going to show this in a little bit more detail. So I'm going to click over here to Mathematica Online, where this is a notebook this is the screenshot that I was creating before, but this is the live version. So if I want to go in and do sine of x over 2x or something like that and recalculate this, I certainly can. But this is the view where I'm in wolframcloud.com. This is Mathematica Online. This is the fully browser-based version. There's no plugin that's needed. There's no installation that's needed. This is a fully browser-based environment. Now, I mentioned that I often publish notebooks and share them. So to do that, there's a very easy way to do that. If I click on Publish, it asks me, do I want a different name or the same name? Do I want to password protect it? Oftentimes I just choose the defaults here. And then if I click Publish, then I get a URL. I get a embed code option if I want to embed this in a web page, or I can just view the page, which I'll do. So this view here, this is my local copy of the file. I log into Mathematica Online, but it's a file that is specific to me. this is now in my published folder, so now I can send this to anyone. I could put this in the chat here in the GoToMeeting seminar. You could all click on this and take a look at my sine wave, take a look at my manipulate, where you can move this slider and you can take a look at all these things and interact with them. So this again is the very the public facing version where you can share this with anyone in the world. Now, oops, hold on here. Okay, I have my slides one out of order here. So I want to drill in and just talk a little bit about how this works. So when you publish a notebook, you can publish from a local installation or browser. So I mentioned that I still use local Mathematica an awful lot. If I go to File, Publish to Cloud, it accomplishes the same thing. Colleagues, friends, students, they can immediately read my project. Anyone can move those sliders for manipulate calculations. How this works though, so all Mathematica Online users have a pool of time on our servers. So when people move that slider and recalculate that sine of x, I have a pool of time on Wolfram servers where that just deducts from what we call cloud credits. So I have a pretty healthy amount of cloud credits. They refresh every month. I would say that for a class, what's provided works very well. If you have a massive open online course, so in the US, we have things like Courseware or edX or things like that. I'd imagine, excuse me, I'd imagine Brazil either participates in Courseware or has open online courses like that. But if there are thousands and thousands of people participating, maybe that might not be enough resources, but these cloud credits go a pretty long way. And then, in general, this web page can link to a published notebook. And I see this happen a lot where someone has a course web page, maybe it is in a learning management system, or maybe it's just on the campus website, but then you can link to a published notebook, and then that's great for a personal project or a publication or course material. So publications we're seeing more and more. So if you have something published in a journal, sometimes you can hyperlink off to supporting calculations or data or more visualizations or things like that. And so a published notebook is a really good pairing to a publication as well. So in addition to publishing an entire notebook, you can also publish just a model or an animation. So I'll quickly talk about that. I find that people want to do this where sometimes in an existing website, you want to embed an animation. And so this is just a really easy way to do that. I'm not going to talk through the Wolfram language code an awful lot, but the major steps here are I'm going to import a PNG file and save that as logo. In Wolfram language, of course, you can blur a logo to a lesser or higher degree. So if I want to blur this 20 times, that ends up much blurrier than 5 times. Manipulate is a way to build a mouse-driven model where I can increase or decrease the blurring of that image. And then Cloud Deploy is a function similar to publishing a notebook, but Cloud Deploy just takes this manipulate and it creates just a URL for that, that and only that. So instead of having a full notebook with all the text and all the code and all that kind of stuff, all this is just the manipulate, just the final manipulate. So if you want to embed this in the middle of a web page and use iframe tags where it's a web page that's done and there's a lot of discussion, but you just want to have an animation in the middle of it, this is a very effective way to do that. This is an example of a few screenshots. So this is a learning management system that I was testing just to show how this might look in a course where oftentimes courses are a mixture of assignments or videos or maybe Word documents or PDF documents or notebook documents, but in some cases, having one of the entries be a sample web application where just embedding that directly works very, very nicely. I've noticed a lot of times learning management systems have a way just to say, do you want to embed another web page in here? And you don't have to know any HTML to do it. It just helps you do it immediately, which was the case here. Okay, so after you publish a notebook, after you publish a notebook, the next question is, and in my case, often I'm doing a training for a group of Mathematica users. So what happens when the recipient wants to adapt a notebook, when they want to add their own data, when they want to take the next step and do something with it? So in this case, I'm going to click back to this published notebook here. So this is the thing that I sent the learner yesterday morning. So in their case, they were obviously a Mathematica user and they were typing along with us as we were teaching them things. So when I send them this published notebook, they really have two options to use their own data and then create their own pie chart. So they can either download the notebook. When they click on that, they just get a regular notebook that they can run in their local copy of Mathematica. It works just like any other notebook. I find at times when I attach notebooks to certain email clients, I use Thunderbird a lot. I sometimes use Outlook, but I actually have several different machines, and I find every once in a while there's a combination where a notebook gets embedded and people have to download it, or they can't directly click on it, or there's just often a few little wrinkles that don't always work immediately perfectly. And as as someone sharing content, the last thing I want to do is test a bunch of email clients to see what happens. Most of the time it works pretty well, but in this case, they can download things. It's very clear. It always works. So I like that very much. And then the other option, though, if the recipient, and oftentimes I'm working with a university campus where there's a site license and everyone has Mathematica Online. So in this case, when they click on Make Your Own Copy, that prompts them to log into Mathematica Online, which I already am here, so I've skipped that step. But when they click on the link, what this does is it creates a separate copy of the notebook where they can now type in their own data. So if they want to type in, that's interesting. Okay, so let me type in an actual letter here. Okay. So if I type in another E, so E went from, I think, 1 to 2, and then I do the pie chart over again, this would be the way that people now start to adapt this and work with their own data. But when they are to this point, they are not changing my original copy of this notebook. They have now created their own copy, and this is in their own cloud storage, and they can rename it. Of course, temp is a terrible name, and they can rename it something sensible, and then use it long term. It's stored in their local cloud storage, which is very nice. Drilling in here a little bit, so make your own copy goes to Mathematica Online, download goes to a local Mathematica installation that I mentioned. But this allows the colleagues or the friends or the students I'm working with, they can now all independently work with this. They can add their own notes, they can alter calculations. It's useful for course materials, it's useful for assignments, it's useful for a publication where if I want to have a peer review some of my code and to give me some comments, I can publish a notebook, they can rerun the code, they can change things, and they can give me comments. And then the recipient of the published notebook, they use their own licensing though. So after they log in or after they download the notebook, these cloud credits that I was talking about in the last slide, those are no longer applicable or relevant. They're just using their own licensing. So that's a nice cutoff where that, that's no longer something that I have to think about as the author of the content. Okay, so now the next thing that I'm going to cover here is web forms. So, and I'm going to go through this a little bit more quickly, but I mentioned that web forms are a mixture of the two. So sometimes manipulate is a good way to share things, but oftentimes if you want something that's slightly more powerful, web forms are a really, really good way to do that. So web forms are something where anyone can perform calculations. A user can upload text or numeric values or equations. Mathematica Online users publish these, and it deducts from their pool of time. It's great for personal websites. It's great for all sorts of things. So in my case, I've done surveys with web forms where I actually collect data and do real-time charts. So if I were guest teaching a class, I might ask people, we just went over this concept. Which of these graphs do you think represents, the concept the best? And students choose one of the graphs, and then I can say 75% of you chose the first graph, 25% of you chose the second graph. Great, we mostly understand this. We can move on. But these web forms are very flexible. So I'm going to show a couple examples, but it's not similar to everything that I'm showing today. It's not an exhaustive list of things that we can do. Okay, so scope of web forms. First thing I want to show is, let me go back to this published notebook. So in this case, I was showing something where, let me go to the original version. So I was showing something where in Mathematica Online, I can move this slider and adjust the, I think this is the frequency that I'm adjusting here. And I can get a feel for what happens as I increase or decrease this frequency. This is defined as f. F goes from 1 to 3, and it's sine f times x over x. And I can get a feel for what happens, in real time. Many people do this in local Mathematica. Manipulate is a very, very useful thing. If I want to take this next step, though, and make a web form where maybe instead of adjusting frequency, I want to have people compare to two different functions. So if I type in cosine of x here and I click submit, what this web form does is it takes cosine and mixes it with the original sine function, and it graphs them both and gives me the answer back. It also does some filling or whatever, but if I want to type anything in here, whether it's related to trig or whatever, I can do that and just compare these two things. And I think 2 space x should work as well for multiplication, and maybe not. Yeah, okay, good. So, but this is just a really flexible way to have a plot utility where maybe this corresponds to a very specific thing in class where I want a colleague to work on something or a student to work on something, and maybe this is something related to my research where I want people to vary something and visualize this. But these web forms are live computation on our server, but I can send this URL to anyone. It's like a published notebook. And people do not need to understand Mathematica or the Wolfram language code to use my finished application, which is pretty nice. This can also use data. So before I was blurring an image, same is true here where maybe I want people to upload their own image. So, they can blur the same Wolfie logo, but I can set this up where they can upload any image here. So I've got another image, although I don't know if this is a PNG file. Let's see. Oh yeah. So I can blur this image, but now this is a very general tool where they can blur any image that they like. And it's a simple example, but it's now generalizable for any different image instead of being hard-coded for one image. People can also work with data sets. So maybe I want to give them a utility that creates a histogram, and you need to upload a CSV file of XY pairs. And so if they upload their own file, then what they get is a nice chart. with some coloring and some, and I have this set up where this is now a cloud CDF. So this, I'm actually looking at a notebook here now. And so I can mouse over and see the bin width here. So there are several values in the high end and low end, and not a lot of values in between. But again, this is a really nice little plot utility that you could give to people. And the code to create this is histogram. So just the Wolfram language function in the middle, but these web forms are created through functions like form function or form page that then specify what should the input of the form be, and then cloud deploy, similar to the manipulate. Cloud deploy takes that and puts that on the web. So lastly here, I'm gonna show a more real world example. So far I've shown a manipulate that's a single line, or a web form that's a single line, but similar to the spirit of ramping this up, I'm going to show a more real world research based example. I have taken this from our Wolfram blog. So Shadi is the head of our image processing group. She wrote a blog several years ago where just highlighting the built-in image processing functionality and how this can be really useful. So the problem at hand here is taking this image, and what we want to do is count the quantity of blood cells in this image. So in research, maybe this is a case where someone is doing an experiment, and maybe they get 50 of these images per hour. And not only do they want to count how many blood cells are in each image to know the result of some sort of experiment or some sort of drug trial or some sort of drug interaction or something like that. So not only do they want to count things, but maybe then they want an aggregate count to look at what is the effect over time, or what is the effect of one experiment versus another. There's a lot of reasons why you might want to do this, but this is a very, I would say, kind of classic image processing thing where really what we want to end up with here is a count and then some analysis. So in Wolfram language, there are functions to do some segmentation analysis, or to count the different unique regions. So this is a view of the unique region where each unique region with based on pixel size here is colored a different color. So now we're starting to count these different regions and to get a feel for how Wolfram language does this. In a similar way, you can draw circles around this and number these. So now we can get a feel where we know our algorithm is counting this blood cell, but is not counting this blood cell. So maybe we want to adjust some thresholds or things like that. But when we're happy with this algorithm, then we can use that. And then, of course, you can do some statistics on this or some analysis on this. So a histogram might be a useful way to see, there's a couple outliers here where the pixel values are pretty high, or there are, several here in the middle, but there's not very many here, in this sort of range. And maybe that's a very interesting result where this is a very interesting group to you, whereas you expected everyone to be in this region. So, that is somewhat hypothetical on my part, but those are the kind of insights that you might gain from this. So I go through this also zooming way out here. So this is a very typical notebook view where this is how people have done things in Wolfram language for a long time, where you lay out a notebook and then you do these calculations bit by bit with some text to outline the ideas. But notebooks are immensely helpful to do these calculations and then create what we call a computational essay to support that. So a couple things if you want to share this. First thing is you could publish the entire notebook. So as a computational essay, if all of that text is very important, of course you'd want to publish the notebook so people can read the text and then follow along with your idea. So publishing that notebook for what I picture as developers, so people that want to create their own image processing computations and use the language for that, or learners who want to, learn about your application. It's people that want to delve into the code. That's a great way to do things. However, there might be someone who is more of a practitioner. So maybe it's a staff member who they need to do these calculations and they need to see the results, but they are maybe a biologist, but they're not a coder. They're not especially interested in how the algorithm was created. They just need to use the finished application. So a web form is great for them, where everything on the last slide that I showed, so everything from here to here is precisely the same. So this looks like an awful lot of code, but it's all exactly the same stuff with form function that specifies that the web form is going to accept a PNG image, and then cloud deploy to copy that to our website, and then an option to say this is public, anyone can look at this, and the results should be formatted as a notebook. And then when you click on this, this is now a much more real world example where instead of just blurring an image, I can copy a new cell slide in here. I can specify a parameter for the histogram. And now when I hit submit, it uploads that image. It runs the, 8, 10, or 12 lines of Wolfram language code. It generates all the charts, and then it gives me back a grid of charts where I can see the graphics primitives and I can see the labeling on my uploaded image, and then I can see the histogram as well. So this is something where, similar to what I was talking about before, this idea of web forms and this idea of all the things I've talked about, they do scale up very, very nicely, where they're not always designed for one-line calculations, or oftentimes we use those for demonstration purposes, but this is now something that is a much more real-world application. It works very nicely, it works very fast, and this is something that I can send to anyone in the world, where they can use this web form, they can upload their own images, and they can use the algorithm that, well, I didn't build the algorithm. Shadi in our image processing group built the algorithm, but it's much more portable now. Rather than just reading about it from a blog, anyone can really use this algorithm now. So I think that's a much different perspective than 5 or 10 years ago. I will and I noticed there was a question about this, but I'll quickly mention that you can share notebooks as well. So if you want to collaborate with someone, there's a share menu where you can type in someone else's Wolfram ID, and then both of you can work with the same notebook. We do not support simultaneous editing at this point, but and I've done this many times myself, if you want to pop in at different times and build different sections in a notebook, the share menu does that. There's also ways to create permissions groups. So if you want to share something to a large group of students, you can actually define that group of students based on their login, and then you can either email them out of our language or email them with functions like send mail, where if you want to have a custom thing, but when you share things, people get this nice message that says, Health and Micho just shared this file. Click on it, and it prompts them to log into Mathematica Online and then do things. So I will very briefly wrap up here. So I think this notebook will be available to everyone. If you're interested in more details about how we help people get started with Mathematica or Mathematica Online or Wolfram Language, or if you're interested in the, how we introduce people to Wolfram Language, myself and the co-authors of this book, I have included links here. I've included links to the seminar as well. This is my email, but we'll do Q&A now. But in general, if you have other questions or things that you're curious about, do feel free to reach out, and I'm happy to give you any thoughts that I have. Hopefully, I'll have some relevant thoughts. But let's now transition to Q&A. I've noticed a lot of the Q&A, Daniel, is maybe not in English. So do you want to focus me on questions, or do you want me to read through the questions?
Yes, let me see here. We have a couple of interesting questions here, Kelvin. I think one idea they ask about applications for cell phones and so on. In fact, we have Kelvin, we have two applications mainly for web for cell phones, right? We have the Wolfram Player and the Wolfram Cloud. What we can do in with the cell phone with Wolfram technology?
Mm-hmm. Yeah, so Wolfram Cloud is what I showed in the initial slides. Wolfram Cloud, let's see, I think it was this slide, yeah. So the Wolfram Cloud app is meant for writing code and creating code. It prompts you to log in right from the start. So Wolfram Cloud is more the authoring environment, more the live computation, but changing things, changing your own notebook's environment. The Wolfram Player app is more like the old CDF player, but across the board now, it's called the Wolfram Player app, even for PC and for Mac. The Wolfram Player app is something where the kernel, it actually installs a Mathematica kernel on an iPad or on a phone. So it's a larger app, but if you share something and it has a slider on it, the sliders move much more fluidly because the calculation is happening local to that device. So those are the two main options, and I would say one is for authoring, one is for users that just want to look at finished things, and I think they're squarely good for one or the other.
Very nice, Kelvin. Another question is about the manipulate on the cloud, okay, using the browser. It says that as you add more controls in a manipulate, it gets slower on the web. In fact, Kelvin, I think we have a different, for example, different behavior from manipulate in the cloud and on the Mathematica, in local Mathematica. Can you explore a little bit about that?
Yes, and that is something that is important to keep in mind. So when so this example, I'm trying to find the one where I'm really logged in here. Yeah, this one. Okay, so this is the view where I am logged into Mathematica online, and so I would say generally things have gotten a lot faster, and especially within the last 6 to 9 months or so. So I'm in Mathematica online here, and I can move the slider, and it is not quite as responsive as local Mathematica, but it's pretty close. 2 years ago, they were not very close, where there was much more of a lag. But it's important to keep in mind, when I move the slider, this really is connecting to our servers and recalculating and giving me an answer back as I move the slider. So it is just like a local manipulate, it is doing a live calculation as I move the slider. When it's local, Mathematica does things in a fraction of a second, so it feels like real time because it can do things so fast. In this case, there is a transit time. So, it has to get from me to the browser, going over the internet to Wolfram servers, doing the calculation, coming back, and then I look at it. And with that in mind, that it really is connecting to a remote machine, that is amazingly fast. I mean, I'm amazed that it is this fast. That being said, there is a point at which, if the calculation pushes around a lot of data, or if the graphic is pretty large, Where that transit time does start to become non-trivial, then yes, that is something that you need to keep in mind. Maybe a web form would work better in that case. Maybe an animation would work better in that case. We will always have the Wolfram Player App as well. So, you know, the idea of the CDF format where you can save a notebook and send it to people and they can install that free player and run the free player, that is not something that's being phased out. And in fact, many people use that still, especially companies and especially consulting companies. So I would say if there's something really intensive going on, still CDF and having people install local CDF still might be the better option. But you know, I will point out the caveat that things have gotten way faster. So in another 6 months, this answer might be different again. So keep checking in with us and keep watching this. But you know, yeah, there's a balancing act there, definitely.
Very nice, Kelvin. We have a couple of questions here. For example, about Android development. Thinking about to create an application for Android to solve calculations for engineering. What is the better approach to do?
Yeah, so for Android, I mean, the question about developing an app boils down to how much work do you want to do yourself? I mean, from my perspective, I am not an Objective-C programmer. I do not know Swift, or I suppose Swift and Objective-C might be iPhone apps. I'm not sure if that's even accurate for Android, but I personally, if I were developing an app, Java, okay, yeah. I'm a very poor Java programmer. I'm a very poor Objective-C programmer. So from my perspective, if I were developing an app, I would develop it in Wolfram language. I would lean on the Wolfram Player App. So I would have people install the Wolfram Player App and then and see how far I can get with that. And I think if there's something like a web form, I might not even need the Wolfram Player App, but I think that would be my first two thoughts. If a notebook is important, where I want there to be some explanation and something where I want people to interact with something, I would try to develop a notebook and then have people run it in the Wolfram Player app where the calculations happen as locally as possible. Or I would just make a website and have people on an Android device just go to this website and interact with it that way. And maybe do part of the project HTML, where it's largely a website where, and you can do that in Wolfram language where you can have it write HTML, but maybe I'd make the HTML myself, maybe I'd have Wolfram language do that, but a web form then I don't even have to worry about them installing any sort of app, whether it's something that is native or something that is Wolfram. They just go to a website and things work very well. I know on iPhone, and I haven't tested this on Android, but on an iPhone, if you want to import an external image, a lot of these click here to upload an image, you know, this goes to my local machine and says, grab this image. A lot of these things work very nicely on mobile as well, where what you get is the My Photos on your actual device, and things work very well.
Very good, Kelvin. We have a couple of more questions, but I think we don't have time to answer all of them now. But we can answer those questions and publish in the Wolfram community later. We have a Wolfram community page for our event. That is, the link is in the event web page. The final question I can ask you, Kelvin, is about they are asking for success cases, projects that clients have been built with Mathematica for IoT, for example. Can you recall some nice projects for our clients?
Yeah, to me, the nicest projects are actually on the Raspberry Pi webpage. And I don't remember if they live specifically on the Raspberry Pi Foundation page or our webpage. But one of our developers, Arnaud, who's on our executive committee, and he's been in the our testing group for a long time. So he's been with Wolfram for a long time as a tester and the manager of the tester, but has grown and moved on and taken on more responsibility. But he's got a couple really nice little projects for Internet of Things, specific to Raspberry Pi, and then our new MicroKit controller guide pages, which I think are the new in 12.0 pages. Those have several nice examples as well, where you can make a serial connection to an Arduino or a Raspberry Pi, and then work with that as well. But I remember Arnaud's being more focused on data collection and specific to Raspberry Pi, but using that where you collect data and then do an analysis on a proper PC, and having some really neat things. So maybe we can add that to community later as well.
Wonderful. Thank you very much, Kelvin, for your help. We really appreciate your presentation. It's very nice. We're gonna move to Professor Pedro from Mackenzie, but I would like to do a poll earlier. The poll is gonna rise up in your screen, and then asking about what your area, what is the... Ok, I can talk em português now, right? Eu passei um poll para vocês, né, que é uma pergunta, perguntando qual que é a área de atuação de vocês. A gente está com bastante gente aqui no evento, né? Eu queria agradecer o Kelvin, né, pela apresentação dele, e a gente vai passar em sequência para o professor Pedro, do Mackenzie. É bem legal a nossa conferência, né, que a gente tem feito aí desde 2013, e dessa vez a gente pode fazer, como estamos online, usar alguns recursos aqui, como os pools, entre uma palestra e outra, a gente pode fazer rapidamente para entender melhor a nossa equipe aqui, nosso grupo. Acho que bastante gente votou aqui. Vou esperar mais um minutinho. Ok. O pessoal ainda está votando. Bastante gente votou. Vamos dar uma olhada agora. Vamos ver. Ok. Vamos ver. Cassidy, are you there?
Yes.
Okay, I did the first poll. Did you see the poll?
Yep. And here we can go ahead. Did you share those results?
Ah,
and
nice.
Then we can see right there.
Ah, it's cool. É o que eu imaginava. Então, assim, muita gente é da área de educação e pesquisa. Depois temos o pessoal, né, que é estudante, e tem bastante gente da área de negócios também, né? É bem bacana. E tem muito robista. Nos Estados Unidos é legal porque tem muita gente que faz homeschooling, que é uma coisa que ainda não tem no Brasil, né? E o pessoal de homeschooling usa muito também a tecnologia Wolfram para ajudar o pessoal em casa. Muito bom.